Okay, let's look at section 9.5 continued, right? So let's define identity function on A, right? So identity function, here's the notation. I sub A is a function from set A to set A defined by, for all A in set A, identity function of A is A, right? So basically this function doesn't change anything. It takes the element A from A and spit it right out, exactly the same thing, right? So that's called the identity function, right? No changes made, right? So let's look at this theorem, right? F is a function from set A to set B. G is a function from B to A. If composition G of F is an identity function, at the same time composition F of G is an identity function, then we can conclude that F and G are both bijective and G is the inverse of F, right? So let's prove that. Alright, first we're going to try to prove that the F is bijective, right? So let's do that. First, we're going to put all the givens first. Alright, so I wrote down all the givens. F has to be a function from A to B. G is a function from B to A. And the G of F is an identity function on A. And F and G is the identity function on B, right? So since we need to show that F is bijective, we have to show that F is one-to-one first. All right, let's do that. So what do we need to show? So we need to show, all right, so we need to show F of A1 equals F of A2 implies A1 plus A2 is equal to A2. Right, so let's try to show that. All right, let's start with f of x1, f of a1 equals f of a2, which is a given. Next line, since g is a function on b, we can apply g to f of a1 and also f of a2, right? If you apply g to f of a1, you get g of f of a1, and if you apply g to f of a2, you get g of f of a2, right? Next line. All right, since g of f is an identity function on A, so line number 3, we know that g of f is identity function of a1 is equal to another identity function of a2. All right, line 8. All right, since identity function doesn't really change anything, so left hand side is going to be a1 is equal to right hand side is going to be just a2, right? Which is exactly what we wanted to have, right? Then we can conclude that f is one-to-one. So I'm using line 5. So f of a equals f of a2. Implies a1 equals a2, right? So f is one-to-one, right? So let's try to show that f is onto, right? What do we need to show, right? So we need to show, number 2, that for all b in B, there exists at least one element in A such that f of A is equal to B, right? So that's the definition for f being onto, right? So let's do that. Right, first, right, choose any b in B. Since it has to be true for any b, right? Then we can have line 11. Since g is a function from b to a, we know that there exists, it's actually a unique element a in a, such that if you plug in b into f, you get exactly the same element a, right? So I'm just using the fact that b is a function from b to a, right? Line 12. Oops, I wrote f, but here I meant g. So this is a g of b, right? Sorry about that. So that's a g of b, right? So line 12. Since f is a function for line 1, we can apply f to both sides of the equation. So you will get f of g of b is equal to f of a, right? Line number 13. Since f of g is an identity function from line 4, we know that we can replace it by identity function on b of b is equal to f of a. All right. The next step, line number 14. Right. Since this is an identity function, it really doesn't do anything to b. So we have, all right, identity function of b is just b, and f of a is f of a. So this is just using the definition of identity function. All right, so therefore, number 15, therefore, f is onto, right? Because for any element b in b, we could find the corresponding element a in set A such that f of a equals to b, right? So final conclusion is, I'll probably put it here, so line 16, right? So therefore, f is bijective, which is a fancy word for one-to-one and onto. So one-to-one we get from line 9, and onto we just got at line 15. Right? That's that. We could establish that f is bijection, or is bijective, because it's one-to-one and onto. All right. Now we need to show that G is also bijective. But you can see that the F and G and A and B are all symmetric. So basically exactly the same argument would work for showing that G is also bijective. So I'm going to skip that, just saying that the proof for G is bijective is done by a similar argument or a symmetric argument. All right, so we got the bijective part done. All right, then what last thing we need to do is we have to show that the G is actually the inverse of the function f. All right, so let's do that. All right, so let's show that G is the same as f inverse. All right, what do we need to show? We need to show that, since f inverse is a function from b to a, and we need to show that, so in order to show that the two functions are the same, we have to make sure that for all b in b, these two functions, so g of b, is always the same as f inverse of b. All right, so let's show that. All right, so let's start with the same givens. All right, then line 5, choose any b in b, so that's given. All right, then line 6, since g is a function from b to a, there exists an element a in a such that g of a is equal to a. Right? Line 7, Since f is a function from a to b, we can apply f to g of b, and we can apply f to a. So if you apply f to g of b, we get f of g of b, and apply f to a, you get f of a. Right? Next line, line number 8. Since f of g is an identity function on b, we know that f of g here can be replaced by identity function of g of b, and the right hand side is the same, f of a. All right. Then line 9. Using the definition of identity function doesn't change anything, so you get b is equal to f of a. And line 10. Alright, so using the definition of inverse function, if f of a is equal to b, then if inverse of b is equal to a. Alright, then line number 11. Alright, since g of b is a, and f inverse of b is also a, so we know that the g of b is equal to f inverse of b. Right? Then therefore, line number 12, therefore, we know that the g is the same function as f inverse. Right? So I'm using line 5 and line 11. Right? So this will establish that the g is equal to f inverse. All right? That's it. I hope that this was clear.